SuperCloud Composer takes a software-defined programmatic approach to managing its ODIM framework by exposing an artifacts repository where OS build images and switch firmware are stored within a central location. Data center operatives have the flexibility to upload specific images either from an URI locator or uploading a custom build image from their computer management station. Custom build plans can have embedded operating systems, application software, and drivers configured within their recipe composition. Let's look closer at SuperCloud Composer's artifacts repository. So let's go ahead and launch the OS artifacts module. And when we launch it, we are immediately pulled into the artifacts repository, where we have a collection of ISO images within the table. We have VMware image, ISO image, Ubuntu, CentOS, and different flavors of Ubuntu. We have the ability to upload a image within the repository by selecting either the file browser location or the URL. And the file browser would be from your desktop, it would be uploaded. And then we have the ability to delete the elements within the table as well. We provide you with the size of the repository, as well as how much free space is left within the repository and what's being used currently. We also have an answer file repository where we provide you with preceded roles within the repository, such as an iSCSI target, iSCSI initiator, NVMe over Fabric initiator target, and GigI host drivers. So the GigI host drivers are used for composition of GPUs and storage utilizing the Fabric's service that's associated with GigIO's network fabric switch. So building composition of a host driver that we can enumerate GPUs and storage. So that's a one-click operation that we provide, and it's stored within this repository. We also provide you with the ability to create your own answer files or upload them from the website. For example, if you had a SUSE Linux type of deployment or an ESXi deployment, you could download those Kickstart files from the internet. And so we also have in our fast deploy service, which is Metal as a Service, we can deploy an operating system within seconds by injecting metadata into its OS build plan. So we allow you the ability to upload your custom-based snapshots or replicas, whether they be Ubuntu, CentOS, or RHEL based. We allow you to upload them within the repository, and we use these particular images for a boot from SAN operation through an iSCSI target service that exists within storage pools of SuperCloud Composer. We also provide you with a switch firmware location. In our case here, we've been testing out the 400 gig Arista switch in our lab. So we have full Arista plugin support. We give you the ability to upload the Arista firmware and also Supermicro switches into this repository. So if I click on the upload option here, you can simply select the appropriate manufacturer of the switch you're uploading, and also the various different SKUs, because there is different firmware versions for different product SKUs of switches. And of course, we have the ability to, again, expose how much of the repository is being used and how much is free and the total size. And then we also have an option here, which is when we're performing an upload, we actually do check some checks on the image that's getting uploaded to the landing pad. It goes through various different phases when it gets uploaded to our repositories of artifacts that exist within our SuperCloud Composer inventory. And again, we expose when those uploads are being executed or performed.